In this example, we are going to convert measures with units from the International Metric System, which is based in prefixes. So part A, let's convert 102 meters to centimeters. Since centimeter has the prefix centi, which means from the table, we can see it means 10 to negative 2 over meter. We have then that 1 centimeter corresponds to 10 raised to negative 2 over meter. Now 10 to negative 2 is the same as 1 over 10 squared of a meter, which is 100. So 1 centimeter is 1 over 100 of a meter. If we cross multiply these quantities, we have that 100 centimeter corresponds to 1 meter, and that is gonna be used as a conversion factor for what we need to do. Now, because we wish to convert 102 meters to centimeters, we're gonna multiply this quantity by the conversion factor that has meters as a unit in the denominator, and we're supposed to remain in the computation with the leftover units as a centimeter. So from the conversion factor, we see that 1 meter corresponds to 100 centimeters. Canceling the common unit, one on the top and one on the bottom, we have that the result is 102 times 100 centimeters. So therefore we have 10,200 centimeters. So 102 meters corresponds to 10,200 centimeters. For part B of the example, we're going to compute how many nanoseconds are in a millisecond. Notice that we have two prefixes from the International Metric System. We have the prefix nano and the prefix milli. Nano means that we have 10 raised to negative 9 of something, in this case seconds. So 1 nanosecond is equals to 10 raised to negative 9 of a second. And we also have the prefix milli, and milli means 10 to negative 3. So 1 millisecond corresponds to 10 raised to negative 3 of a second. We are going to use these as conversion factors for going from millisecond to nanoseconds. So to convert 1 millisecond to nanoseconds, we use chain conversion of 1 millisecond. First, let's transform this to seconds. So since I wanted the result to be in seconds, and cancel out millisecond using the second using the second conversion factor, we have that 10 to negative 3 seconds divided by 1 millisecond correspond to the value 1. So 1 millisecond times 10 to negative 3 of a second divided by 1 millisecond cancels the unit of milliseconds. So this answer would give me the value in seconds, but my answer should be in nanoseconds. So now I'm going to multiply by another conversion factor that will take care of this. So the final answer should be nanosecond, and I should cancel out the seconds. So my conversion factor from the first part is that 1 nanosecond corresponds to 10 raised to negative 9 seconds. Putting this into my conversion factor that I'm multiplying to convert milliseconds, I have 1 on the top, 10 to negative 9 on the bottom. And that would cancel the units of second. So the leftover unit is nanoseconds. So now we just need to carry on the computations. So this results in 1 times 10 negative 3 times 1. So the result is 10 to negative 3 nanoseconds divided by, in the denominators I have 1 times 10 to negative 9. So 10 to negative 9 is in the denominator. Now we're going to carry on properties of exponents. So for the division of powers in base 10, the common base 10, we subtract the exponent. So we keep the base, which is 10, and subtract the exponent. So minus 3 minus the bottom exponent, which is negative 9. So this is in nanoseconds. So we have that 10 to negative 3 plus 9 nanoseconds would be the answer. So this is equals to 10, 9 minus 3 is 6. So 10 to the 6 nanoseconds. That is the same thing as 1 followed by 6 zeros. So the answer is 1 million